99% is not enough. I'm here to talk to you about test coverage. It's a really big subject, and I'm not going to cover it fully. Haha. Some quick disclaimers, though. I'm not here to judge anybody. I'm extremely undogmatic. I maintain some libraries with like really awful test coverage. I know we're all mostly bad. We're do our best to improve. That's all we can do. My goal here is just to try and show a better path and share a way forward. And I know you're going to forget these disclaimers and get mad anyway. That's fine. I just still felt like it was worth saying. So you're here at Assert.js. You probably write tests. A test is a program that runs your code, and it verifies that your program does what you think it does. Programs need tests. I think we all know that. And if a test is a program, what tests your test? Usually it's this lump of meat in your head. This should be a little bit terrifying. So typically what we do is we run the test and then we just look at it and we're like, fine, move on. I've been writing software now for about 25 years and JavaScript for most of that time. And one thing that I've had to learn over and over again, because I'm stubborn and dense, is that humans are terrible at software and we're too stubborn and dense to actually acknowledge this. Like literally just the other day I caught myself thinking I was good at JavaScript and then I spent 3 hours figuring out why this promise wasn't resolving. It's because I was calling process exit. I should know that. Yeah, meat brains suck at this. Seatbelts are good. Seatbelts don't cure diseases. They don't stop aging. Even if you wear a seatbelt every time in a car, eventually, and I'm sorry if I'm the first one to tell you this, you're gonna die. That's a guarantee. But seatbelts save lives. Because in complex, dangerous situations, we augment our brains with technological help. Software gets pretty complicated, even if you're doing everything right. They're fixed in their definition. Programs are fixed when we define them, but then the context that they're in changes because we want to use it in a new way. We want to use this library in some other application. So what that means is really there's an unbounded number of things to keep track of. And complex systems are always in a state of partial decay as a result. Coverage is a meta test. It tracks that what parts of your program were executed by the test that you ran. Coverage tells you how much of a test your test actually is, basically. It doesn't prove that your program is good. It doesn't prove that your test is good. It doesn't prove that you're a good person or a competent developer or a kind and loving partner to your friends and family. None of that. All it does is these are the lines that got executed by this test. It's verification that your test ran your program. So I want to talk a little bit about the effects of exposing costs. A lot of the talk around about TDD or about other kind of testing practices are really about bringing costs from later in the development process and pulling them up to the very beginning. If your tests are brittle and they have to be updated on each change, well, then that's going to make 100% test coverage really hard because they're brittle. So use snapshots. Make them less brittle, basically. Follow all the good practices you heard about today. If you have to mock the whole world to hit some buried line of code, we could just not test. No, take that buried line of code, put it in a separate module. Voila, you've just written better code. Full coverage isn't about writing code with more tests. It's about writing code that is more testable. So there's also some cases that I found that were a little surprising for me as I got more and more bought in on this idea over the years, is that coverage is a test extender. One thing that was always a pain for me was if I'm caching something or if I'm memoizing some function response, you got to use like some inversion of control goober and like stick it in there, and then you have to like refactor your whole code base so it can take no, just run it twice. The coverage will tell you if you hit that code path or not. Voila. Less than 100% test coverage means that you have a component without tests. It means that you have some part of your code which is not being tested. Basically, you can look at a 95% covered program as two parts. It's the covered part and the uncovered part. And you're just using this module that's used without any tests whatsoever. If you can't delete it, which a lot of times is the right thing to do, it's a great way to get to 100% test coverage. Just delete all your code. If you can't delete it, then you should probably write tests for it so that you can maybe know what it does, because your meat brain is so bad at this. So those are all kind of like negative reasons. What are some more of the positive reasons? Full coverage actually makes you look in the dark corners of your code base. And that investigation process tends to uncover bugs and help you see new and better ways to design and implement things. You'll notice like, oh, hey, we're doing this in a really inefficient way. Like, that is kind of dumb. Maybe I should like make that better. It lets your meat brain do what it's good at, which is like creative kind of exploratory thinking, while the computer keeps track of whether or not you've hit this line or not. But that's all the boring rational reason. And we don't care about boring rational reasons. We care about emotions because meat brains are so dumb. And one of the things that's really awesome about test coverage, about full test coverage in particular, is that going from like 98% test coverage to 96%, that's okay. Well, we should probably write a test. It's not that bad though. Going from 100% to 99.5% feels awful. It's so bad. It's like, oh, the green turned yellow. I can't believe this. Oh my goodness. And that getting to that row of green 100s on the test output, it's just like, it's this delicious high. If you've never experienced it, I strongly recommend it. Little bit of a fair warning though, it's incredibly addictive. It will trick you into being a better developer. How do you do it? So, and again, what this means, you're just covering all lines, branches, functions, and statements. Node tap has a flag you can pass in --100, and it will automatically do this and fail the test if it doesn't have 100% test coverage. If you're using NYC, there's options for each one of those different things. And basically, this gives you superpowers. OK, I'm going to go through some of the objections I've heard, mostly on Twitter, but also in person. It takes so much time. I don't want to do it. Full coverage does add upfront dev costs, but it reduces the amount of time that you spend like arduously going through and trying to figure out bugs and like, oh, why did we do that thing? I don't remember. And like, oh, we needed this code for some reason. I think if we deleted it, it might break somebody. I don't know. Full coverage exposes that cost right away so that you're not paying interest on that technical debt. Oh, my linter, or I use types. How many of you use TypeScript? You probably don't need tests, right? You're joking. So pretty soon after it's written, if not before, you actually don't know what your code does. The chances of it being bug-free are effectively 0, even with full coverage, because you're going to use it in a new context at some point, and it's not going to work the way you think it does. So test coverage doesn't prevent all bugs. What it does is it gives you the power to be able to fix those bugs more efficiently. Well, people will just write really bad tests that are doing dumb things in order to just get to 100% coverage. Like, newsflash, people are going to write bad tests regardless. They're going to write bad tests with 95% coverage. In fact, they'll probably write more of them and they won't cover your whole code base. The solution is just to write better tests and to force yourself to build components that are more testable, that you can get to 100% coverage, not to just accept that some things are not testable. I also find it really fascinating. Nobody ever said to me on Twitter, I've heard this objection probably more than any other. Nobody has said to me on Twitter, well, I'm going to write really crappy tests to get to 100%. No, it's always the other people on my team, those dummies. Yeah, they'll do it. Not me. No, I'm a good boy. Oh, I'd have to like create a zillion fixtures on 4 different operating systems to simulate. OK, here's another fun thing about testing. You can do some just like awful things, some things that would make your hair curl if you saw them in production code. Like you can just monkey patch the file system. You can mock out the HTTP library so it just like returns the same response all the time. That's actually a good thing to do. There's a module called mutatefs. You can make it fail any arbitrary file system call. I use it a lot. Only testing the happy path is practically the definition of works on my machine. You have to test your error checking code because your error checking code is important. You wouldn't use an untested error handler, but you are if you're not testing those code paths. So what about things that really, really cannot be tested, right? Like I have this function and it tests, if A is true, else if A is false, and there's no way that it could possibly be one of those, other than that. Okay, so you throw an error at the bottom to be like, this is untestable. All right, so if it's something like that and you're willing to stake your reputation on it, I've got some cheat codes for you. Istanbul ignore next, if and else, will tell it to ignore the next line. So you can still have 100% test coverage, but with an active declaration that this little bit of code is something I'm not going to test because it's impossible. But what if that's not enough? What if you want to upgrade even more? Full test coverage, yeah, what if you're accidentally covering things? So in tab 14, there's a flag there called coverage map. So you can pass it the name of a module that exports a function that takes a test path name and it returns an array of files under test to cover. This is great for cases where like I have a base class and I want to make sure that the base class unit test fully covers it and it's not just getting covered by like the test for other classes that extend it. It makes it a little bit harder to get to 100% test coverage, but it also improves all of those benefits because it makes it easier to refactor, knowing that everything is covered by a test. You can always find where the test is for it. Some over time, just a quick reminder, I'm not here to judge you. I also commit all of the sins that I have told you not to commit. Do as I say, not as I do, and keep getting better. Wear your seatbelts, test your programs. Here's places you can find me in order of how long the URL is.